We begin by identifying the data type for the desired hardware faults. So we can copy the relevant hardware data type to the clipboard. Then we paste the data type into the Logix Designer Help search box and open the relevant search result. Based upon the descriptions, we should be able to identify the fault status member that provides the desired data and take note of its data type. In this example, the hardware tag structure for a 1756 digital output module contains a double integer member that aggregates all of the individual point faults. Thus, the desired data type is double integer. However, for this 5069 digital output module, we find a single bit that indicates when any of the module diagnostics are active. So, in this case, we would use a Boolean data type. Now that we know the correct data type, we can create a program InOut parameter within the relevant program module. If the hardware tag structure has the faults aggregated into a single member, then we connect the new parameter to the member. For the active diagnostics bit, we connect the Boolean parameter to the hardware diagnostics bit. Now we can create a Boolean program output parameter that will eventually report the status of the hardware to a supervisory level program. Each hardware module will have a similar status bit. All of the various hardware status bits may then be combined in the supervisory program to provide permissives or interlocks. Permissives can prevent a machine from starting, while interlocks can stop a machine that is already running. With the necessary parameters created, we can add a new rung within the status routine for the relevant program module. For aggregate faults, the rung should be conditioned with an equals instruction. We set source A to the aggregated faults program parameter. Source B is set to the constant 0. So if the fault parameter is equal to 0, then there are no faults in the module and the rung has logical continuity. For a single bit, we can condition the rung with an examine off or XIO instruction assigned to the diagnostic bit parameter. So if the diagnostic bit is 0, then there are no faults and the rung has logical continuity. Now we place an output energize or OTE instruction on the rung and assign the hardware not faulted parameter to it. When we have a supervisory level program, we can connect the hardware not faulted output parameter to the relevant parameter in the supervisory level program module. We do this for each hardware module in the project. Because we chose the InOut usage that updates synchronous to the hardware's RPI, the fault data will always be as up to date as possible.